Introduction to Biomass. Biomass refers to biological substances either living or dead in a specified area. In the context of this assignment, the word really refers to energy that is created by the use of growing plant materials. Biomass is one of the oldest energy sources, and it has been around since cavemen learned to create thermal energy through burning wood. Most of the biomass on planet Earth originates because of a chemical process called photosynthesis. Engineers in this field use the ecological pyramid to determine the amount of chemical potential energy that can be converted into chemical kinetic energy through photosynthesis. Types of biomass: wood and agricultural products. As most of the biomass today is homegrown, much of the energy comes from many types of wood, like logs, chip, bark, and sawdust, which accounts for 44% of all biomass. Solid waste. Solid waste mainly refers to the burning of rubbish that can be turned into an energy form that is usable. Almost 50% of its total content comes from plastic. Landfill gas and biogas. Another common type of biomass is landfill gas and biogas. The way that this type of biomass is converted into energy is through fungi that eat dead plants and animals, which leads to rot and decay. This fungi then creates cellulose sugars that feeds itself. Ethanol and biodiesel. Ethanol. Ethanol is an alcohol fuel that is made by fermenting the sugars and starch in plants, which distills them. Biodiesel is formed when a chemical reaction between vegetable oils, animal fats, or greases, like what comes from leftover restaurant takeaways. Biodiesels are usually mixed with petroleum diesels in quantities of around 2, 5, or 20%. Here is a photo of a biomass power plant. If you look to the far right hand side, you can see the conveyors where the wood is loaded into the storage area. Wood is then passed down from dry fuel to the second main compartment where the hot water boil is. The heat of the combustion boils the water to make steam, which powers the turbine. All the leftover flue gases go out of the chimney. Due to this process of combustion, most of the useful energy continues through to the turbine in the third main compartment, through to the generator. In the generator, the energy carried from the turbine is turned into electricity. Here is a diagram of a biomass power plant. So below I had the energy transfers. So in step 1, the wood is being burnt, which turns to steam. So it's being converted from chemical potential energy to thermal kinetic energy. That steam then passes through to the turbine. So in step 2 you can see that. And then the thermal kinetic energy turns into mechanical kinetic energy. And then in step 3 you can see some of the mechanical kinetic energy being recycled through the district heating network, where it's turned back into thermal kinetic energy. And then in step 4 you can see the energy that is not recycled turning from mechanical kinetic energy to electrical potential energy as it moves to the generator. Finally, in step 5, you can see the electrical potential energy in the generator being turned into electrical kinetic energy. This is a pie graph showing the percentage of biomass as a total of renewable energy. In this graph, biomass represents roughly half of all renewable energy, followed by hydro, wind, geothermal, and solar energy. Positives and negatives of biomass production. Positives. Renewable. Biomass is a renewable energy source, meaning the positive of this energy production is that biomass power is created by taking advantage of renewable assets on Earth, like organic waste. Less reliance on fossil fuels. By using biomass, we can reduce the heavy importance and reliance that we place on fossil fuels, like coal and gas. Carbon neutral. Biomass is carbon neutral, so it means it is a better energy alternative to other fuel sources, like coal or gas, that discharges carbon into the environment. Widely available. It is a widely available energy source because it comes from many organic materials that is waste, like dead leaves, grass and trees, and animal carcasses, which are available in large quantities. Therefore, if these materials keep growing, biomass will continuously be a way to produce energy. Flexible energy source. It is a very flexible way to produce energy because you can create many different products from several varying forms of organic matter. Smaller consumption of waste. Biomass can help manage our consumption of waste as a society because we would use less solid waste like biodegradable waste, recyclable waste, dangerous toxic waste, and consuming it and turning it into energy. Negatives. Creates pollution. Although biomass is carbon neutral, it still creates pollution when types of biomass like wood and other natural materials are burned. Contributes to deforestation. Because wood is a big source of biomass energy, large amounts of it and other waste products need to decompose for it being burnt. Though this results in trees having to be cut down, which can cause deforestation and destroy many animals' habitats. Inefficient. Some sources that are used to create energy through biomass can be quite inefficient. Take, for example, producing biodiesel. The main component in creating this type of energy, ethanol, needs to be mixed with gasoline to speed up the process. Requires lots of space. Finding a place where a biomass energy plant can be situated can be very difficult because it requires a lot of space and has to be placed in more rural areas where they can obtain enough land. Lastly, it is very expensive. The cost of production and biomass is very expensive, and sometimes the energy that can be produced does not always make up for the cost. An example is that the transport and gathering the materials for the power plants are high and need to be done each day. Conclusion. Should this energy source be used extensively? After weighing all the positives and negatives of biomass production, I have decided that it should not be used extensively. My first point is that although biomass may seem appealing because it is renewable and carbon neutral, those points are mainly irrelevant because biomass is known to produce as much pollution as fossil fuels when burning organic matter. That means that if biomass is used each day, it will still form a lot of pollution and contribute to growing problems like global warming and climate change. Secondly, even though there are many resources for biomass, the power plants take up a lot of space and have to be placed in rural areas, which contributes to deforestation and more traffic in those places. Therefore, it could be argued that if this energy source were to be used more, a lot of land and nature could be lost gradually over time. This could include destroying many animals' habitats and angering locals. Lastly, biomass could redirect focus from heavily relying on fossil fuels, and it is flexible in the sense that the different types of energy can be formed from using different organic matter. Although, since biomass has been known to produce as much pollution as fossil fuels, and it has been known to be inefficient and less effective than normal petroleum and less effective. For example, producing biodiesel takes a long time to produce on its own and has to be mixed with normal petroleum diesels in different percentages. Along with this, biomass energy is very expensive to make, and if it were to be used extensively, you would have to add other factors like gathering the organic matter and transport, which would add up to lots of money over time. Therefore, due to the reasons mentioned above, I believe the arguments I have made about biomass are stronger than the counter arguments that could be made.